Hello, my name is Phat Dinh, and today I'll be presenting over the optimization of polyethyleneamine functionalized spongy monoliths for lipid nanoparticle separations using liquid chromatography mass spectrometry. So what are LNPs? LNPs are drug delivery vesicles, and they are composed of ionizable lipids, cholesterol, pegylated lipids, and phospholipids. Previously, LNPs are commonly separated using SEC. However, the drawbacks of SEC include the need of conditioning and saturating the LNPs onto the column prior to analysis. There are also secondary interactions between LNP and SEC columns. In Figure 1, we monitored the peak area of LNP after each consecutive injection onto SEC column, and the peak areas can be seen to increase after each injection. We found an alternative to combat these shortcomings: spongy monoliths. Spongy monoliths have low back pressure due to large pore sizes, low absorption due to low surface area, and are modifiable with different functional groups due to the presence of epoxy groups. The functional group that we chose is polyethyleneamine, since it can decrease electrostatic interaction between LNP and the column. In the past, PEI have been used in capillary electrophoresis to separate proteins. However, our goal is to be able to construct an online multimodal LCMS system for encapsulation and efficiency determination, with the focus of this project being the synthesis of a sufficient trap column. For methods, the empty LNP synthesis procedures start with the preparation of reagents that are composed of ethanol lipid mixture and an aqueous buffer. The next step is rapid mixing using the pipette technique and a ratio of 3:1 aqueous to ethanolic mixture. Lastly, the LNPs are dialyzed in PBS buffer 3 times. As for the PEI functionalized monolith general synthesis procedure, we first started coating the monolith with ethylene glycol before pushing it into the housing. The excess column is cut off, only leaving 2 to 3 millimeters sticking out. We then hook it up to an LC and rinse the column with acetonitrile for 1 ml per minute for an hour, before rinsing it with water at 1 ml per minute for another hour. After the rinse, we manually push 7% volume by volume PEI solution through the column using a syringe, and finally the column is sealed and incubated at 40 degrees Celsius. Prior to using the column for analysis, the column is rinsed again with water at 1 ml per minute for an hour. Moving on to the results. In Figure 4, the column we use is a 600 molecular weight PEI monolith that was reactive for 24 hours. The LNP eluted before the dead time, which is what we wanted. However, the peak areas for the LNP increase after each consecutive injection, indicating that there is absorption of LNP onto the column. In Figure 5, the column we use is a 2000 Dalton PEI monolith. In this case, we were able to see an improvement compared to the 600 Dalton PEI monolith, as the column is saturated with less injections. However, this is still not ideal. In Figure 6, the column we use is a 2000 Dalton PEI monolith that has been cross-linked with ethylene glycol diglycidyl ether, or EDGE. We also modified the reaction conditions to using a PEI solution with a pH of 11 by adding 0.1% triethylamine. For analysis, we changed the aqueous mobile phase to 0.1% formic acid from 50 millimolar ammonium acetate. We were able to separate 2 distinct distributions of LNP, with the later eluting distribution possessing 4 times more cholesterol than the earlier eluting one. We also confirmed this using mass spec by lowering the flow rate to 0.25 mils per minute. In Figure 8, we wanted to see the retention mechanisms of these LNP on a saturated SEC column. We first saturated the column with LNP. We then injected heavy LNP onto the column and monitored the signals for DSPC and DSPC-D70. With more injections, we were able to see a stronger DSPC-70 signal and a weaker DSPC signal, indicating an equilibrium-driven process. To conclude, PEI molecular weight, pH reaction time, and addition of cross-linking step all contributed to the reduction of LNP adsorption onto the stationary phase. 2 distinct compositional distributions of LNP were observed and separated on the monolith, with the later eluting distribution possessing 4 times more cholesterol than the earlier eluting one. Separations of LNP compositional distributions have only been done on CE, and this fast separation is done on LC, ideal for high-throughput experiments. Coupling the LC with MS is also very common, and this is ideal for optimization of LNP formulations and quality control purposes. For future works, we plan to optimize the end capping step to increase surface coverage, column characterization using elemental analysis, frontal analysis, and scanning electron microscope. And finally, a profile retention with an analyte test mix that is composed of RNAs, proteins, and small molecules. Thank you for listening.